So now I want to write the likelihood function for the derivation of the negative binomial regression or to estimate the parameter from the negative binomial regression model. So likelihood function. So likelihood function of the negative binomial regression. So likelihood function for one observations is written. Okay, so let me write it. Factorial n could be written as n plus 1 gamma. Okay, so gamma 10 equal to factorial 9. This is the relationship between what is gamma and what is factorial. Okay, so likelihood function y I plus this likelihood function for one observations, because it is easier to write the likelihood function for the one observations, and after taking log of the likelihood function for one observations from the transformed negative binomial distributions, if I sum over them, then it is mathematically convenient. Okay, so this is the likelihood functions for the one observations. Written everything in the format of a gamma, and then it is written 1 over 1 plus alpha mu I over 1 plus alpha mu I yi. So remember, we consider theta equal to 1 over alpha, right? If 1 over alpha is in there and 1 over alpha is in there, if we take out this, if it's cancelled out, it takes this format. Okay, if you see like different kinds of format, because it could be mathematically written in this format, so that likelihood function get a nicer look. Now L, so log likelihood for n observations. So if it is taken log likelihood of n observations, now log likelihood of n observations could be written as L equal to log of L. It could be written as n. I goes 1 to n, and log of n, then yi. This is log. Natural log is written like this, and yi plus this minus ln minus ln yi plus 1 then I want to take here minus this ln yi ln alpha mu I. Let's go. Yes. And minus yi. That should be plus. That should be minus ln 1 plus alpha mu I. Okay, can any one of you tell me where can I plug x beta? Where can I plug x beta? Can any one of you tell me? Because take a look at that. Take a look at that. I consider log of lambda. Last time I considered log of lambda equal to x beta. X beta can be written as beta 0, beta 1, x1i, beta 2, x2i, and it will go all the way beta k, xki, right? Right? So this is the way log of beta, log of lambda was replaced by x beta like this. Now I want to replace x beta in which part in here? I want to replace x beta in where? Where? Okay, in this case, where is my mean parameter? Mu, right? So where should I put e to the power x beta? Right? Do you understand? Because we are predicting on an average, right? So now take a look at that. If I write this likelihood function in original, suppose now let me go, let me write like this. For one observations, I want to write likelihood function like this: x plus r minus 1 factorial and factorial factorial x and r minus 1. Okay, then p to the power r and q to the power x. Where can I put my x beta? There is no mean, right? We cannot put it in here x beta, right? But here is mu, where I can put x beta. Are you understanding? So all the discussion, last 1 hour and 45 minutes, the discussions that I have made in order to convince you that now I can plug x beta in there. Do you understand? So now few students are laughing because all the 1 hour 40 minutes, 1 hour 50 minutes I spend my life in order to show that x beta can be placed only in mu I, because mu I is the mean. You understand? Mu I is the mean, but this negative binomial distribution, that does not have mean. I cannot plug in x beta. So the scientists, our forefathers, they worked days and night, keeping the formula same. Okay? You understand? Same thing, better format. See, now I am sweating because 1 hour 50 minutes I have discussed all of these things in order to bring a mu, which is the mean of the distributions. Now what I am going to do, there is no mu. I do not need any of these things. I do not need it, because if you differentiate these things, that will go, because my betas are in there, right? So I can consider all of those as my, take a look, L, log of L, and this is sum, and I goes on to there. This quantity, I just want to make a constant C, and there I want to make like this, L and 1 plus alpha mu I, and then plus yi ln alpha plus yi ln mu I minus yi ln 1 plus alpha mu I. Now just plug in there. Now just plug in there e to the power x beta. Plug in there e to the power. I want to plug in there e to the power x beta. I want to plug in there e to the power x beta. So x beta takes loop what format? X beta takes loop format beta 0, beta 1, x1 I. Right? So what are you going to do? You are going to differentiate these things, right? Okay, you are going to differentiate these things and you have to solve it. Okay, so that will be your, if I write it very simple, Newton-Raphson method, that will be my first prime of x, right? So you have to solve Newton-Raphson method x x plus n f of x and double x, right? So this is your first one. Then you have to take the second one. dl square dl beta square, something like this. And then you will find these two things, and then there is a numerical solutions would be obtained. Analytical solution is not obtainable. Clear? Analytical solution is not obtainable. Down the road, anything comes to your mind. Well, I do homeworks like this and that, but I do not know how they compute all of these parameters. These are the mathematics working behind the Python and R. When you write the code and run, they use Newton-Raphson method, first derivative, second derivative, and then they estimate the results and give you the results. Understand? So there is a, how many parameters is in there? All of these things, beautiful matrix format, Hessian matrix, okay? And then this formula is used. Very useful formula. 400 years ago, Newton, he discovered these things. It is still we are using. Okay? 2 hours, exactly 2 hours I spent to derive these things. Now let me show you homework. Where should I go? I should go there. Okay, let me download all of this. Homework download, and then binomial, this one download, and then Poisson download. Okay, these 3 downloading is done. Let me open these things first. Take a look, your homework problem. Please pay attention, okay? We have 25 minutes, pay attention. Download the homework 2 data from D12 and use it for this homework. Variable CEB1 is original variable in the data. The data was a real data, but CV2 variable was simulated. Denote homework 2 data as D1 in R or Python. You have a freedom. Thoroughly read documents, reading NBR and reading PR. These are the 2 documents that I want you to read. 1, 2. Okay. So in one of the question, I ask you to do this plot. Let me explain this plot to you, okay? Are you seeing here is written general, academic, and vocational? Okay. And there is a predicted predicted days absent in the class. Okay, predicted days absent in the class. In this case, it will be your CEB1 or CEB2. Understand? And this will be your what? This will be your the variables that you have created. First, create a categorical variables with 4 levels. Okay, these 4 levels that you have created for an existing variable, that will be your here. Okay, and here you can take any continuous variable. Here you take math score. So that way they have created this figure. You will create this figure. Here will be your CEB1 variable or CEB2 variable. One for the Poisson, one for the negative binomial. Okay. So this will be your CEB1 or CEB2. This variable and that variable you could keep same. Okay. See, general, academic, and vocational, right? In your case, what will be? It will be see. First, create a categorical variable with 4 levels, 1, 2, 3, 4 from an existing variable. I give you a clear instruction. An existing variable could be region or AOR, which is age of respondent, or RW, which is the respondent weight, or RH, which is the respondent height. Clear? You have to choose only one of these 4 variables to create a categorical variables with 4 levels. In this figure, there are 3 levels: academic, general, academic, vocational. But your level, how many? 4. Okay, that variables you will create from one of the variable region, AOR, respondent weight, and respondent height. Clear? Now what you will do, you can take region variable which is a 7 level. You can transport that 7 level to 4 different levels. I give you the instructions. If you do not like region variable, you can take age of the respondent or respondent weight or respondent height. Read the instruction thoroughly. Okay, okay, I will grade these things very carefully. How can you record this variable? Because first homework you did and you know how to record a variable. Okay, now a student with odd student ID number. In the homework submission, you must write your student ID number. Students with odd student ID number must use either region or respondent weight to create a categorical variable. Safari, what is your student ID number? Last number is odd or even?
Odd.
So you have to use region or respondent weight to create a categorical variable which will have 4 levels. Okay, which will have 4 levels. Which will have 4 levels. And those people who has a even student ID number must use AOR and RH to create a categorical variable. Remember, if your student ID and the variable does not match, automatically you will get 0. Charity, Ololade, and Shafali, and face-to-face people, everyone is okay?
Yes.
What you will get? You will get 0 if your student ID and the variable does not match. Okay, very simple. I discussed a lot of theory, give you a lot of pain during the class time, but make your life easy in the homework. Because in the daily life, in industry life, what you will have to do, you have to know how to apply those things. But if I come to the class, I spend like discussing this and then give you, okay, do all the homeworks, that does not mean the graduate class. When I was get training to master's degree and PhD, I was got training like that way. That's the way your foundation has been built. Understand? Now your homework is easy. Now take a look. By checking CEB1 and CEB2 variables, come up with the decisions about using one of them as a response variable for Poisson regression model and other as a response variable in negative binomial regression model. How can you do that? Fantastic. Check the mean and variance. If mean and variance are equal, go with the Poisson. If mean and variance are not same, go with the negative binomial. Okay. Choose at least two quantitative variable. So in your predictive variable, how many continuous variables should be there? At least two. At least two quantitative or continuous variable. Okay. Suppose Shafali choose respondent weight as the categorical variable. Then Shafali can use AOR and RH as her continuous covariate. Understand? At least two. Because respondent weight, age of the respondent, respondent height, these three are continuous covariate. And then you have to choose one categorical covariate with 4 levels that you have created in step 1. Okay. If someone use just 3 variable, for example, if Shafali use AOR, RH, and the variable she created in step 1, that is what she does his work. Okay. Now, in order to predict the CEB and constructing curves similar to this, in the y-axis, it should be CEB1 or CEB2. This one. For Shafali's case, it should be CEB1 one time when she will feed Poisson. Another time it will be CEB2 when she feed. I don't know which one, okay? That is what you will decide. And in this case, 4 levels that she created, she is going to use that one. And in this case, math score, she can use either AOR or RH. Clear, right? Okay. After doing that, I want choose at least 2 continuous. Okay. Give the explanation of the parameter estimates in terms of incidence rate ratio. Okay. Incidence rate ratio, how to explain those things, incident rate. Please read these 2 documents. Reading these 2 documents will not take more than 30 minutes from your life. Okay. Attentively, if you want to read, it will not take more than 30 minutes. But you are talking with your mom and then your friend and then others and maybe your spouse or new girlfriend, then it will take 2 hours, 5 hours. Understand? Just 2 documents, right? If those documents, if you read thoroughly, then you will understand how real life that could be applied. I gave a very simple material. Okay. Create graph similar to the one shown in the class with 4 levels of a categorical covariate. Okay. Redo problem 2 and 3 for the negative binomial regression by choosing appropriate response variable. So suppose if you do for steps 1 to step 5 for the Poisson, then you will have to do these things again for the negative binomial variable. If you do it for the Poisson, then again do it for the negative binomial for the Poisson one. 2 figures corresponding to Poisson regression model and negative binomial regression model or dependent variable would be expected log count corresponding to a variable of choice, and the categorical variables with 4 level that you created must be added to the report. Write a 2-3 page report with all the graphs and all the regressions output that you are seeing. You have to give explanations for those. For example, let me show you. When you run these things, so there is the output. Are you seeing log, click, these things? And Yeah, what is the null deviances? So give a explanation for this, okay? And residual deviances, give a some explanation for this. 1-2 sentences is fine. One, two sentences is fine. Write a short report for each output obtained by running the Poisson regression model and negative binomial. You must provide R script or Python script and a report written in a Word document. In the Word document, in the written Word document, you must put the student ID and your name. Okay? Student ID and student name. The Word document that you are going to create, your name and your student ID so that I can match it. Okay? In the report, you must explain the findings from the model fitting and prediction. Very easy work, okay? And I have provided you R code, but if you do it Python, I will be really happy because I have given you something, but you did it by it. This is the R code. This R code is run on these Poisson simulations and on this data. These data and that data are used for running Poisson regression predictive modeling and negative binomial regression predictive modeling. Clear? I have given you mathematical derivations. I have all of those things written very beautifully here, but I did not add it. But if you need it, I can give it to you. If you are planning to go for PhD, please focus on all of these things. Down the road, if you change your mind, well, now I know all of these things, I will go for the PhD, and these things is necessary. Foundation is very important, right? Any questions, comment, problem? No,
I have
right?
a question about the homework.
Yeah.
Can you go back to the Word document, please?
Sure. Yeah.
So for number 7, just to be clear, where you say the expected log count, that is just for the modeling, right? The figure does not have log count in the y-axis.
Let me show you.
It is just count in the y-axis, right?
Okay, when I do these things, if we do you remember we write here log, come on, with the Poisson, which is log of lambda equal to what? X beta, right? So this is expected log count. This is okay. And if you put here just lambda, then it is equal to X beta. Okay. So when you get the output, take a look. What did you put? Did you use the log or you use just the regular mean? If you use the log of mean, then one time, and then if you do not use the log of mean, then it will be just expected count. So expected count in the figure means where is my that one? I already closed it. Okay. So let me open it again. Predicted days absent, right? So it could be like predicted, like this is predicted days of absent is the expected log count, something like this.
Would it be expected log count or expected count?
Okay, so
Question.
that depends.
Okay.
That depends on the situations. Like in the original regression model, how are you putting all of this? Let me see what the this is written. Program. Yeah, see, when they feed, they put it here log of that. Okay. So that means you either have to explain this expected log count, but if log, if you take in the right side, then it will be incidence rate ratio. If you do not want to explain expected log count, then log will go to the right side, and in that case, it will be exponentiation. You have to write it incidence rate ratio. Okay, I have 8 more minutes. If you do not have a questions, I'm just going to stop in here, and your exam will be on March 7 before spring break. How about that? Is it okay? Or if you want, you can do it maybe March 7 if you do not like. You can do it February 29. March 7, right? March 7. So few problem will be given from like the homework one. 4, 5, 10 problems maybe will be given from there. Homework one. Homework one has 40 problems, right? Okay. So and then remaining problems is coming from the portion negative binomial. Next class I'm going to cover very quickly the speed of light. So this regression, heuristic net, these three. I hope I will be able to cover these things. And after that, I will cover maybe mixed effect model, something like this. So we will have before the midterm, we will have 2 more classes, right? I will try to cover those models. Okay. So if you have a very big covariate, suppose you have 100 independent variables, you are not sure which one to include in the model. Okay. How can you do that? So these elastic net and lasso, if you enter them, they will kick out unimportant variable. Okay. This was developed in 1996 and 2007. So those are the things I'm going to discuss in next class. Okay. See you in next week. Good luck with the homework. Bye.
See you.